think we are up with time. Shall we
Yes,
begin?
Dr. Ashish. Yes, Dr. Ashish. Please go ahead.
Or shall we wait for a couple of minutes? We start sharp at 12:05.
Mm,
See, people are still joining in.
Okay, we can wait a couple of minutes more.
Okay. Good morning and welcome to all the participants to this webinar. Hi, Dr. Ashish Unarkhat. Would like to welcome you to this webinar on a very interesting topic of innovation-based case study on industrial process development, which is organized by the Department of Chemical Engineering at School of Technology, Dean Petroleum University, Gandhinagar. Those who are new, for them, PDPU, Pandit Deen Dayal Petroleum University, is a NAC accredited A-grade autonomous university which is being established as a private university, State Act in 2007. Over this more than a decade, the university committed to excellence in research, teaching, training, and consultancy in the different domains of engineering, technology, and management. Ready world-class professionals. In line to the intent of the university, we are striving to inculcate and imbibe the innovation in the emerging professionals. This is one of its kind that will drive us on the path of innovation with enriched case studies from our esteemed speaker. Very delighted to introduce the speaker of the day, Dr. Anandit Gupta, who is currently associated with PDPU in the capacity of being the chairman of IPX committee and senior mentor with PDPU. Dr. Gupta has over 3 decades of association with IOCL and he superannuated as an executive director. During his tenure in IOCL as R&D, he has worked on extensively in research in fuels and additives, biofuels, biotechnology, bitumen, extraction, creation, and one of its favorite topics of IPM. He was instrumental in development of various award-winning products and technologies during his tenure. Few to mention are having multifunctional additives for diesel, daily driving school model, transportation of BS3 and BS4 fuel across the country. He was also associated with the prestigious auto fuel policy, which were formed in 2003, and a vision and policy of Government of India in 2025. More than 80 national and international patents to his credit, along with 150 research papers in high-impact peer-reviewed journals. Now, under his leadership, most of his patents were commercialized and the technologies were passed to the industries. That is what makes his impactful research. It is too small to talk about the accolades of Dr. Gupta here, who stands as a visionary and a researcher who has been strived through his life to a development of our technologies and product. With these words, I would like Dr. Gupta to take over and enlighten us through the. Over to you, sir. Thank you.
Thank you, Dr. Ashish. Am I audible?
Yes, sir. It's audible, sir. I'm stopping the screen share. You can start your screen share. Thank you, sir.
Thank
you. Just an announcement to all the participants. All participants should keep their audio and video off during the webinar. If you have any questions, you can drop your questions in the chat box. By the end of webinar, Dr. Swapnil will be coordinating your queries. Thank you. Over to you, sir. Thank you.
This screen is visible to one and all, I suppose?
Yes, sir. Very much visible.
Okay, friends, a very good afternoon to all of you. So I am told that most of the participants are students. So therefore, I prepared my presentation come discussion in such a manner so that it should be very easily understandable to the students and of course to the professors also. So the topic of my presentation is innovation-based case studies on industrial process development. Now, the total presentation is divided into two parts. I'll give a small background, why background that I'll discuss, and then I'll discuss with all of you three very important case studies. Now, why these case studies? And what for these case studies? They are basically based on innovation. And these case studies basically created IPR, that is patents. And they are related to the oil refineries. So what I'll do is, in the background, I'll be discussing very briefly about the innovation, creativity, what exactly is the IPR, and how this IPR is relevant, and how this is related to the refineries and what are the refineries. And that I'll do it in a brief manner. Now, what exactly is the difference between innovation and invention? Now, the invention is basically has got two very important key features, that is creation and the first time. So invention can be defined as the creation of a product or introduction of a process for the first time. Then when we talk about the innovation, of course, there are so many definitions for innovation. The one which I like most is, it is basically the process of translating that invention or the idea into a good or service that primarily creates the value. So that is difference between invention and the innovation. When you do invention, what exactly you do? Either you publish or you go in for patenting of that particular invention. What exactly is the publication? It is basically the act of making something generally known in the form of a book, in the form of monographs, in the form of research papers, in the form of articles in newspaper. I mean, so that anybody and everybody would get to know what exactly you have done. Coming to the patent. Now, patent is different than the publication. Patent is an exclusive right granted by a country. This is very important. This is country specific. So granted by a country to an inventor, allowing the inventors to exclude others from making, using or selling his or her invention in that particular country during the life of the patent, right? So patent would not compel you to make or market or sell your intervention or your innovation, but it basically excludes other from making, using and selling of the invention which you have made. Now the life of the patent is 20 years. Now, if you have an invention and you go in for publication, you will not get any monopoly whatsoever. And it can be commercially exploited by others also. So therefore, if you do a very good invention and publish, then you publish and perish. On the other hand, if you've got an invention and you go in for a patenting process, you will get legal protection for 20 years. You get the monopoly, right? So therefore, you can channelize and you can do further research and development. And eventually, if you do patenting, you'll prosper. Now, patent is basically converting Saraswati, that means the knowledge, into Lakshmi, that is the money, right? So these IP rights will basically convert your knowledge into money. Of course, both Saraswati and Lakshmi, they have got their own relevance. For example, Saraswati, these patents will give national and global recognition, not only to the individuals, but to the organizations also. It helps in career progression. And most important thing is that one patent can get you more than one publication. This is very, very important. If you come across a very good innovation, instead of simply publishing a paper, you file a patent, and there is always a possibility that after filing patent, you can have more than one publications. Coming to the Lakshmi, patents can be monetized. You'll get a lot of money out of it, and inventors may earn huge revenue after commercialization. So both Saraswati as well as Lakshmi, they have got their own importance. But if you convert Saraswati into Lakshmi, additionally, you'll get a lot of money in the form of monetizing patent, or you'll get revenue after commercialization. These are basically the photographs of Indian patent, US patent, and other patent, just for your information. And very important thing, industry prefers patent for commercial reasons. Industry never wants that the work is to be published. Of course, a work which is not of interest to the industry, they'll say, okay, go and publish. But normally industry prefers patent basically for the commercial reasons. So this was basically about invention, innovation, and the process of patenting, and what are the rewards you can get out of patenting process. Very quickly, I'll discuss with you about the petroleum refineries in our country before coming to the three very important case studies. See, in India, we have got 23 public as well as private sector refineries, and they are processing to the tune of about 235 million metric tons of crude per annum. This is as per the data published on 6th of April 2020. Now, there are basically two types of refineries. I would say broadly two types, otherwise it could be three or four types. One of them is a refinery which is making only fuels, starting from gases, LPG, to gasoline, jet fuel, diesel, kerosene, and the fuel oil. And this is the simplistic configuration of fuel-based refinery. There is another type of refinery which basically makes and processes lubricant oils. So you take the residue from the atmospheric distillation bottom and process using different types of refining processes, and you end up with lubricants. And these lubricants, along with additives, would produce lube oils, which are being used in so many applications. But there is another type of refinery, which is a combination of these two. That means a single refinery making and processing fuels as well as lubricant oil. And the classical refinery in our country is the Chennai Petrochemicals Limited, CPCL. It's the only refinery in our country which is making both fuels as well as lubricants. There are other types of refineries also which are integrated with petrochemicals. Of course, it has got no direct relevance with this particular presentation. So therefore, I am not going to discuss about those types of refineries. Now, up till now, I have discussed with you the three aspects: innovation, invention, IPR, and what exactly is the refineries. So these particular three case studies are basically related to all these three aspects which I have just discussed with all of you. Now, in all the three case studies, the strategy which my team has adopted was basically providing simple solutions to the complex problem. But simple solution is the toughest challenge. Simple solution doesn't mean that you go and do it and the thing would be in order. That's the toughest challenge. So all the three examples which I have taken in the form of case studies are basically providing simple solutions to a very, very complex problem. So I'll start with the first case study. This case study is basically for producing mineral turpentine oil from Nigerian and Persian Gulf crude oil. This is basically value addition to the refineries. This is a very complex refinery. I'm not going to discuss, don't worry. I'm not going to discuss about this particular thing because this is a very, very complex process. But most important thing is that along with fuels and lubricants, refineries are also making solvents. And this MTO, or mineral turpentine oil, is one of the very important solvents being used industrially in so many applications. Indian Oil, for example, is a bulk producer of mineral turpentine oil. And this MTO has got a narrow boiling range of 145 to 205 degrees centigrade. And the most important thing is it should be colorless. The Seibold color rating should be better than +20. And the MTO is being manufactured by some of the Indian oil refineries. They are meeting the Bureau of Indian Standards specification, that is IS 1745 1978. Now, the most important thing for making MTO is that high sulfur and nitrogen containing crude oils are not suitable for the production of mineral turpentine oil. Another important aspect is high nitrogen and sulfur crudes are the cheaper crudes. So if you look at the Indian scenario, all our refineries are basically made and tuned to take worst quality of crude to produce best quality of fuel. Means we are processing and we are procuring very high sulfur and nitrogen containing crude oils because they are cheaper. And therefore, since we are importing about plus 85% of our crude oil, so therefore this becomes very, very important with respect to making the two ends meet with respect to the economy. So Nigerian crude and Persian Gulf crude oil, they contains huge amount of sulfur and nitrogen. So therefore, these types of crude oils are not suitable for making MTO, which should be water white and it should be free from sulfur and nitrogen species. Right? So there is a big challenge because one of Indian Oil's biggest refinery, that is Panipat refinery, they are processing Nigerian and Persian Gulf crude. And they also wanted to make mineral turpentine oil because in the northern part of the country, the requirement of MTO is enormous. So they posed this particular challenge to Indian Oil R&D Center to devise a process or to develop a process by which high sulfur and nitrogen containing crude oils can be used for making mineral turpentine oil. Why color is very important? Because MTO is often being used for dry cleaning purposes. So therefore, if you have color, it will basically make your clothes colored. It is also being used in the paint industry. And MTO is also being used in different processes as a solvent. So therefore, if you have high amount of nitrogen and sulfur, it affects the catalyst. So therefore, removal of nitrogenous compounds and sulfur becomes very, very important in order to make a good quality mineral turpentine oil. What are the processes for making these types of MTO? Treatment with sulfuric acid, treatment with caustic soda, and catalytic hydrotreatment. But there are issues. Your refineries, they are not processing in kilograms or in tons and all that. They are processing everything in million metric tons. So therefore, handling voluminous amount of corrosive minerals and alkali at the refinery is not advisable at all. And second thing is, if we are using catalytic hydrotreatment, hydrogen being very, very costly, it is making the process uneconomical. And therefore, the cost of MTO would go very high and it would not be affordable for the customers. So therefore, aim for the present invention is to propose an environment-friendly, that means avoiding acid and alkali, very low energy process, because the moment you increase the energy of the process, the cost will go up. And of course, a cost-effective process, preferably based on adsorption technique. Because that is one thing which can be put up at the refinery at a very, very low cost, number one, and the processing time is low. So therefore, this particular aim was there for this particular case study. So at Indian Oil R&D Center, we developed a process for making MTO having the boiling point in the range of 145 to 205 degrees centigrade from the worst type of crude oil, that is Nigerian crude oil and Persian Gulf, which were rich in nitrogen and sulfur, as I have discussed with you just now. Now look at the regular process at the refinery. There is a distillation section wherein crude oil comes and it is being distilled into different fractions. A particular fraction which is boiling in the range of say about 130 to 250 is basically separated and treated in the Mirox process, wherein sulfur is deactivated. And from there, you do a distillation in order to get a product which is boiling in the range of mineral turpentine oil, that is 145 to 205 degrees centigrade. Up to these three sections, everything is possible and everything is in position in the refineries. But the problem is of color. So what we did was, this is the innovative step. What we did, the rundown MTO from the previous section was subjected to liquid phase adsorption using molecular sieves, modified clays, and mixture thereof. And the most important thing was the temperatures were ambient. So therefore, we can save on the energy, and the pressures were also ambient. So you need not to have higher pressure applied onto the process. So what we did, it's a very simple sort of thing. We put up a column, which we call as a clay filter, which was filled either with the molecular sieves, modified clay, or mixture thereof. And we get MTO, which is meeting the requirement of Bureau of Indian Standard specification in the same boiling range and water white. So therefore, look at this particular thing. A very, very simple solution to a very complex problem. Because none of the refineries in any part of the world is making MTO from crude like Persian Gulf or the Nigerian crude. So therefore, this is a very, very simple solution to a complex problem. So what we did was we used molecular sieves of different types. We used a modified clay, which is known as Filtrol 24, very readily available in the refineries, basically for production of aviation turbine fuel. So nothing we imported, nothing we bought from outside, everything was available, even the column was available in the refinery. So the total cost of this particular project was to the tune of only 5 lakhs, which is nothing. Another important thing was that these clays and molecular sieves, which are being used for making this MTO, a water white MTO, can be regenerated also. And it can be regenerated by passing a high nitrogen stream at a temperature of about 200 to 300 degrees centigrade to regenerate that particular clay or the molecular sieve, so that you can keep on recycling the same molecular sieves and clay in the process for at least 200 to 300 runs at a time. So this process was upscaled at the Panipat refinery, and commercial production started from 2001 onwards. A very, very interesting story, which I'll discuss with you at the end of this particular presentation. We filed Indian and US patent, and you'll be glad to know, or you'll be surprised to know, that we got this particular patent within 2 years. That US patent, we got it within 2 years. So this is one case study. Second case study, which I want to discuss with all of you, is another very important aspect, that is dioxane removal from benzene. And this is basically for customer support. You must all be knowing Nirma. So Nirma in mid 90s, I think it was around 1998, 99, they set up a linear alkyl benzene manufacturing plant based on solid catalyst. So that was the first plant which came to our country, which is also known as the Dettol process, from a process licensor called UOP, right? Universal Oil Company. So that is based on the UOP technology. And they positioned this particular plant very close to the Indian Oil Refinery of Baroda. So this is basically the schematics I'm not going to discuss. It basically takes olefinic feed and it produces linear alkyl benzene and heavy alkyl benzene. So they require a very specific type of benzene. It should not have dioxane content more than 1 ppm. Dioxane is a chemical I'll discuss with you a little later. So the concentration of dioxane, because dioxane is the poison of the particular process, so therefore the concentration should not be more than 1 part per million. And at the Gujarat refinery, the same UOP has provided a technology which is known as UDEX that was operational, wherein the refinery was using a chemical called TTEG. That is, can you just mute it, please? So the UDEX plant is basically using TTEG, that is tetraethylene glycol, for extracting and making benzene. But when we tested this particular sample of ours at the Gujarat refinery, we found that the dioxane concentration was to the tune of about 1000 parts per million. So there was a big challenge to cut down 1000 parts per million down to just to 1 parts per million. This is basically the schematic of the UDEX process. It takes naphtha, going through various processes, including the extraction. It basically gives benzene, but of course, having large amount of dioxane content. So Indian Oil then approached UOP because the process license with Nirma was also from UOP, and our process was also based on UOP technology. UOP in turn advised, because they said that with this particular TTEG, it is next to impossible, it cannot be done. So therefore, you'll have to convert entire process either onto the sulfurylate extraction or to the NMP extraction, which was costed at that point in time was about 600 crores of Indian rupee. So of course, it was a big money. So therefore, this particular problem was referred to Indian Oil R&D Center for technical intervention. So how we have approached and what innovation we did. So first and foremost, my team basically tried to understand how this dioxane is being formed in the benzene. Since TTEG is being used, wherein ethylene glycol and diethylene glycol, they are basically the impurities. So ethylene glycol, 2 moles of ethylene glycol in presence of sulfuric acid, it forms dioxane. And this is basically the mechanism for that. And if you have diethylene glycol at elevated temperature in presence of acid, it forms dioxane. So we came to know that dioxane, why dioxane in excess quantity is present into the TTEG. So our first strategy was, if you want to cut down the dioxane from the TTEG, the concentration of ethylene glycol and diethylene glycol should be substantially removed from the extractant tetraethylene glycol. So this is one strategy we adopted. Second thing which we found out, that dioxane form azeotrope with toluene, because toluene is one of the impurities or one of the components of the benzene, and certain amount of toluene is allowed in the specification itself. So we found out that dioxane forms toluene. So if you cut down toluene concentration, eventually the dioxane would also come down in the downstream of benzene. This is the second innovation and strategy we adopted. And then we finished the rundown benzene with the liquid phase absorption using molecular sieve and modified clay, which we have used earlier for MTO process. We had that sort of experience with us. So therefore, adopting these 3 strategies, we did trials in the laboratory, and we found that yes, we can achieve a benzene having less than 1 part per million of dioxane. So we did plant trials in the then IPCL at Baroda. And what we did was, we approached the TTEG supplier and we said that we want TTEG having less than 0.5% of ethylene glycol and diethylene glycol, which he gladly supplied to us. And at the pilot plant trial, we could generate benzene with less than 1 part per million of dioxane. So pilot plants were really successful. We presented this thing to our management, and management in turn took up with the NIRMA, and we sent samples to NIRMA, and NIRMA approved those samples. So look at this. This is a very simple solution to a very complex problem. The complex problem was that as per UOP, we were supposed to revamp the entire process basically to produce benzene having less than 1 part per million of dioxane. But what we did, we provided a very simple sort of solution so as to make dioxane-free benzene in the existing system. So we did successful commercial trial in our Gujarat refinery. We produced large amount of benzene. We had given samples to NIRMA. NIRMA approved those samples, and since then we started supplying Detal grade benzene to NIRMA on a sustainable basis. So in the process, we filed both Indian as well as US patent, and here also we got this particular patent in about 2 years' time. So this is another success story or a case study which I wanted to discuss with all of you. Now, third case study is also very important and very interesting case study, that is making alpha olefins from coker kerosene. And this is basically converting waste to wealth. How waste to wealth? That I'll be discussing in the ensuing slides. See, this is a typical coker-based refinery. And in Indian Oil, the Barauni refinery, which is there in the northeastern section of our country, or the part of the country. So they have got a big coker unit, which basically produced, along with different type of products, industrial fuels. Now these industrial fuels contains very valuable crack products. Crack product means olefinic products. They contain a lot of alpha olefins and normal parabens. They are very valuable raw material for making different types of value-added chemicals. For example, you can do with the alpha olefins isomerization to get streams which can be used for high octane gasoline. You can do metathesis to get different types of linear internal olefins. You can do oligomerization to have medium molecular weight products. You can do dimerization. You can do isomerize. I mean, you name a chemical reaction, you can do it. This particular stream from the coker-based refinery was basically a sort of waste refinery, waste stream, but it contains a very valuable component, that is alpha olefins and normal parabens. Now, there is a small story behind why we have taken up this particular project. See, in around 90s, this particular refinery, Barauni refinery, was not getting substantial amount of crude oil for processing. So refinery was basically looking for some avenues, some projects, which can basically add value to the refinery, to make refinery profitable. So when we presented this sort of project to them, that look, there is a possibility of making alpha olefins and normal parabens, which are being used for making linear alkyl benzene, which is which can be sulfonated to make detergent and dispersants. So therefore, immediately they said, yes, fine, we'll give you this particular stream, and if you can value add, it's a real service to this particular refinery. So that's a background. So how alpha olefins and paraffins are isolated? There are basically two processes. adsorption and desorption process, and the extraction process. What we did was, we did a different type of approach. We performed different type of operation, which is known as urea adduction. It's not a new process. It's a very, very established process. It is being used in Japan for a very, very long time, basically for separation of linear products, not exactly alpha olefins and paraffins, but other type of products. And they've got a running refinery here. So urea adduction is a separation technique based on size exclusion. Now, very important thing is, I'll show with the help of certain schematics and slides that what exactly is the meaning of size exclusion, how it is getting separated. Another very important aspect is the conventional urea adduction process basically generates urea solution. And if you want to regenerate urea from that particular solution, you require tremendous amount of heat to basically distill off and evaporate water, basically to get the solid urea. So there were two challenges. One is to separate linear alpha olefins and paraffins. At the same time, avoid this particular step of having aqueous urea, because then the economics becomes really, really unviable. So I'll show you some very important here. This I was discussing that conventionally the crystals are basically dissolved in water. This is a conventional method. Once you dissolve, it goes into the water. And if you want to regenerate urea, then you'll have to remove the water, which is a very, very cost-intensive process. Now, urea is a very, very peculiar sort of chemical. It has got spaces in between, which are long and narrow. The average diameter is to the tune of about 5 angstrom. And these spaces are large enough to include linear chain products, excluding branch chain and the bigger products. So this is basically a crystal structure of urea. This is the urea adduct, in which the paraffin and alpha olefin, which are linear in nature, they are entrapped. So you take linear, say for example, decane or dicene. Dicene is olefin, decane is alkane. So these are linear products. They go and sit into the lattice of urea because of their size. Their size is, the cross-sectional size is never beyond 5 angstrom. So therefore, they can very suitably go and sit into the matrix of urea. But if you take a branched alkane, it will not go because the size is too big. Likewise, if you take cyclohexane, right, it will also not go because of the size of this particular molecule. Or if you take a steroidal molecule, it will also not go inside, right? So therefore, based on the size exclusion, only linear paraffins and olefins can go inside the matrix of the urea crystal and forms urea duct. So therefore, second important aspect was that through this particular process, we got pure and reusable urea instead of urea solution. So therefore, huge amount of energy was avoided. So the total process was divided into 4 steps: formation of the adduct, separation, decomposition, and the finishing step, basically to get linear products out of it. So we developed a novel process by which we have isolated alpha olefins and normal paraffins from a base product, that is coker kerosene from Urb-Biruni family, and also recovered solid and reusable urea. How we have done it? So instead of putting the stuff into the water, basically to dissolve the urea so as to separate the alkane, we sheared it mechanically. You have seen how the juice is being made. It is basically taking out juice from the matrix of a fruit. So we have taken that sort of concept, and we did mechanical shearing of the urea adduct, basically to separate hydrocarbon product and the pure urea. So that's the innovative step which we have used in this particular process. So look, it's a very, very simple solution to a very complex problem. It has added to the economics of refinery at that point in time. So we did a pilot testing at the Hindustan Insecticide Limited, which is situated in Gurugram. And then we scaled up this particular process along with the Barauni refinery and the process team of Indian Oil. And then we put up a 1 metric ton pilot plant at the Barauni refinery with the help of a agency called Blue Star. So here also we filed Indian and US patent. And the beauty of this particular process and the novelty of this particular process is that we got this particular patent. I think you'll be able to see it. We filed this patent on December 3, 1997, and we got US patent on December 8, 1998. That is, in 1 year, the process was so unique that we got US patent in a year's time. So that's another success story of this particular process, which I wanted to discuss with all of you. Now, I have already discussed 3 case studies, and I thought I must discuss, because I have discussed with you about the importance of patent, importance of innovation, importance of simple solutions for complex problems. So I must share with you a very, very interesting fact sheet. See, going back to the mineral turpentine technology, that is MTO technology, which we developed in 2001. And we set up this particular process in one of our refineries, that is Panipat refinery, with the investment of just 5 lakh, in the range of 5 lakhs. And we filed patent in 2001. The commercial production started in that year itself at the Panipat refinery. And I superannuated from Indian Oil in December 2014. So that means the process during my tenure, it ran for about 13 years at the refinery. And we have calculated something. We have calculated the profit accrued by the organization till 2014. And this particular, in this particular process, we had a team of 5 members. We did some back of the envelope calculations, and we found out that the MTO profit earned by the refinery during 2001 till 2014, that is about 13 years, it covered salary plus perks plus bonus plus travel of all the 5 scientists for their entire service period with Indian Oil. So that's the beauty of providing simple solution to complex problems. So since most of the participants are students, I thought I must discuss this particular fact sheet with them so as to ensure them, to make them convinced that, look, 3 things are very, very important: innovation and creativity. Number 2, if you do innovation, go in for patenting. And while developing a process, look for simple solution for complex problems. And in the process, not only your organization, you'll also earn huge amount of money out of it. So this is what I wanted to discuss with all of you. So this is basically the power of a simple solution to complex problems. So with this, I would like to conclude that innovation and creativity, they are key for new product and process development. And as I have emphasized, that aim should be to provide simple solutions to complex problems. If you have a simple solution, the industry would accept it, they'll adopt it, and your process or your solution would see the day of the light. While doing all these three case studies, we used extensive simulation and modeling, basically for upscaling process. And the success story basically lies on these type of exercises done by my team, simulation and modeling, so that directly from the bench top to the commercial unit, we could bring in all the three major products. Patents are very important tool, as I have discussed with you. They not only give you recognition, but also give you a lot of money. So with this, I would like to conclude. And before conclusion, I have 2 slides to share it with you, because in this COVID scenario, before that, I would like to acknowledge my lead and director, Dr. A.K. Bhatnagar, for his sustained encouragement and confidence in me and my team. He had a lot of confidence in us, and fortunately, we lived on that. And my team of brilliant scientists at Indian Oil R&D Center, and some of my team members are online, and they're also watching their success story being shared with all of you. And also to my dear colleagues at PDPU Gandhinagar for providing this opportunity for presenting this particular important aspect to all of you. This is a COVID time. My suggestion would be that you please stay safe. Always wear mask. Keep distancing. Please maintain distancing. Sanitize yourself. Do not touch your face to the extent possible. And always wash your hand. And another most important thing is stay inside, stay safe. Look at this particular slide. You'll never be run out if you stay inside, if you stay in trees. So therefore, message is stay inside, stay safe. Thank you very much. And you can follow me on LinkedIn. This is my LinkedIn ID, www.linkedin.com/in/my full name, Dr. Dr. Anurag Atit Gupta. If you click this, you go to my site, and you can see me there. If you want, you can follow me. So
Yeah. Thank you, Dr. Anurag Gupta, sir, Senior Mentor of PDPU Gandhinagar, for enlightening us with very informative session on innovation-based case studies on industrial process development. I think sir covered significance of innovation and invention at the beginning by showing various useful case studies with industrial relevance. Sir also mentioned that how to deal with the complex problem with a simple solution. He also highlighted how to convert waste into the wealth. So I'm pretty sure that this webinar given good insight to the participant about the applicability of the engineering concepts in industrial process and development. So I, Dr. Swapnil Dharaskar, Head Chemical Engineering, now like to keep the forum open for the discussion and the questions. So first of all, we will take few questions from the chat box. So I request Dr. Anurag Gupta, sir, please address the concern. I'm reading the first question. What is the use of MTO in PET industry if colored MTO is not acceptable?
see, if you cannot remove the color from the MTO, it is downgraded to kerosene. So MTO is being sold at a price of about 30 rupees a liter. It's a ballpark figure. And kerosene is 10 rupees. So look at the value addition. So if you have a colored product, it will be sold at the rate of about 10 rupees. Whereas if you value add, you'll get 3 times more the price of this particular product.
Okay. Second query is how the 3 steps were decided in your second case study of dioxin. What the molecular sieve adsorption purpose in this particular process?
Yeah, basically molecular sieves are just like urea lattices, and they also capture polar entities, right, which have got a definite size. So that is also based on size exclusion basis, and therefore the type of molecular sieves which we have used, right, they can capture dioxane into their lattices, and the special clay or the modified clay or the Filtrol 24 which we have used in the process is basically for the adsorption, because it absorbs the polar component. So it is basically absorbing the polar component and releasing the entire benzene, which is less polar compared to dioxane.
Okay. Third query, could you please share some insight on the recently occurred gas leakage from LG polymer incident at Vizag?
I think this is a question which is not interest to all of you. So you can address this particular question separately to me, and I'll separately answer.
Sure. There is one more query, difference between patent products and commercial product.
Come again?
The difference between patent product and commercial product.
Patent product and commercial product.
Yeah.
See, I mean, you can commercialize anything, but if you do not have patent, then anybody can copy and make it. So you don't have exclusive right for that. But if you have patent, and after patenting you are commercializing, nobody else can commercialize that particular product. Nobody can make that particular product. So therefore, the advantage of having patent is exclusive right to you.
Okay. There is one query from final year chemical engineering student. Sir, I'm highly interested in process designing and development. Would a master's in process engineering be beneficial to me at this point where jobs are hard to acquire?
So why don't you answer, Dr. Swapnil?
Yeah. Okay, no problem. See, definitely we can. You can go for the master's program for process engineering. That will definitely give you the advantage in the future. And as far as the chemical engineering part is concerned, this particular course will give, will provide you lots of insights how to deal with the various industrial based problems. So I must say you must go for the master's in process engineering if you are unable to get the job in this COVID situation. Thank you. Last query from chat box. The second case study, we wanted benzene at very low EG/DEG for TTEG. So how we can we get the benzene? Any special specific process for that?
No. See, benzene process, I have shown you the process sheet. So benzene is being made at the refinery itself. But only thing is, since we were using TTEG, tetraethylene glycol, right? So therefore, tetraethylene glycol has ethylene glycol and diethylene glycol, which basically cyclizes to form dioxane. So therefore, by reducing the concentration of EG and TTEG into the, EG and DEG into the TTEG, followed by reflux management to cut down the concentration of toluene, because toluene forms, it basically boils along with dioxane. It forms azeotrope, right? So first strategy was to cut down EG and DG, ethylene glycol and diethylene glycol from the TTEG, so that within the system, dioxane should not be formed. If dioxane at all is forming, it will go along with the toluene as a second phase, wherein we are maintaining or cutting down the toluene concentration. And even the remaining, maybe say 3 or 4 or 5 parts per million of remaining dioxane will be taken care by the finishing step with the help of a modified clay. So that's the total process.
Yeah. So this is all about the questions from the chat box. Now I request to the participant, if you want to ask the personal question, you please raise your hand. So for a time being, I can unmute and start your video. You can mention your name and then you can ask query. So if anyone is there, just raise your hand. Okay, if there is no further query, I would like to, yeah, just a minute, Keshav Mishra. Yes, Keshav. Yeah, Keshav, you can ask your question.
Hello.
Yeah, Keshav, go ahead.
Hello.
Yeah,
Yes.
Keshav, go ahead.
Sir, sir, what are to selected PSUs
Sorry,
and
I cannot hear you. Sorry, I cannot hear you.
I think, Keshav, you want to ask the question that for job, we go for get into IITs for higher packages or go for PSU like ONGC, IOCL or BPCL. Am I right?
yes, sir.
Yes.
Look, dear, choice is yours. Now, both academics as well as in industry, right? I mean, it is your personal choice. Both are giving you a lot of satisfaction, lot of freedom to work, right? And scales are also very good. So it all depends on your attitude, your understanding, your preference. If you have knack for teaching, right? If you want to build nation leaders, then you should join academics. But if you want to do some sort of very exclusive research, and if you want to contribute to the society through technology, etc., then industry. So choice is entirely yours. Right now, there are equal opportunities both in academics as well as in the corporate world. So it's entirely your choice, your bent of mind.
Okay, thank you. So now I would like to conclude the session. I, Dr. Swapnil Dharaskar, Head Chemical Engineering, along with my team Chemical, says thanks to all the participants for your active participation in this webinar. I'm very much grateful, Professor Anurag Gupta sir, to sparing his time and delivered an excellent talk on the innovation-based case studies on industrial process development. I must acknowledge Director SOT and PDPU management for providing all kind of support and always motivating us to organize this kind of webinar. I'm also very much grateful to our IICC student chapter team and IT team for the extension of all kind of supports. So I think all of you enjoy this session. So thank you all. It was a pleasure for having you all here, and we're expecting your feedback through email. We will very shortly we will share some the feedback form with you, all of you. I request you all, you please provide your feedback through the email. Thank you a lot. Thanks a lot.
And if,
Have a good day.
just one second. If
Yeah.
anybody wants copy of my presentation, please contact Dr. Swapnil Dharaskar. I'll
Sure.
share this particular thing with him, so that if you require, you can get a copy of my presentation also.
Right. So we will share
I
the
have
copy of the
questions, sir.
presentation. Rishabh.
Huh, sir.
Yeah. Okay.
Sir, like,
But
what is the procedure for patents, sir? Patents.
I
Rishabh,
cannot hear. I think
yeah,
voice is breaking.
Sir, he just wanted to know about the procedure of the patent.
Process
How to
of
file the patent.
See, process of patent basically requires three things. Whatever you develop, it should be novel. It should not be reported anywhere on the earth. And third and most important thing is, it must have social application. So if your invention or your new thing meets these three requirements, then there is a prescribed format. You put up your invention in that particular format, and with the help of a patent attorney, you can refine it and submit it and file a patent.
But sir,
Yes.
is there any organization for patents, sir?
No. In fact, Indian Patent Office is the organization which basically do the patenting process. So you can approach directly, right? Or you can approach through patent attorney. going through patent attorney would be advantageous initially for 1 or 2 patents, because they'll advise you what is to be reported, what not to be reported, and how this is to be reported, right? So there is a patent office in every country. So you'll have to approach that particular patent office. But if you are filing any patent outside India, so there is a mandatory requirement that you must first file that particular patent in India.
Okay. Yeah, thanks to all.
Yes, sir.
Yeah, thanks to all. It was a
Thank you,
pleasure
sir.
having you all. We look forward your feedback through mail. Thanks a lot. Thank you. So I request all the participants, you can log off.
So Swapnil, you want to discuss something with me, or should I?
No, sir, no, we can log off.
Okay, thank you. Thank you, and Dr. Ashish.